We ended the last video talking about the gravitational force. Today, we will discuss the electromagnetic force. Similar to the gravitational force, the electromagnetic force is also mediated by fields, but it is mediated by electric and magnetic fields. We can even map out the magnetic field of a magnet using iron filings. Although the gravitational force and electromagnetic force are similar in that they act over large distances, there are some very important differences that we want to address in this video. Unlike gravitational forces, the electromagnetic force can be attractive or repulsive. It is also much stronger than the gravitational force. For this video, we're going to focus on electric fields and forces between charged particles. This is a special case of the electromagnetic force that is known as the electrostatic force. Before diving into the electrostatic force, I wanted to show a quick example of the repulsive nature of electromagnetic forces. Here's a GIF showing how, even without touching, a bar magnet can exert a repulsive force on another magnet, pushing it away. The image to the right uses iron filings to illustrate the electromagnetic force exerting this invisible repulsion between the magnets. Check out the electric field hockey simulation linked to this video to explore the electromagnetic force further. We saw a demonstration of this electromagnetic force in the last animation, but we still need to find ways to model these forces. For this, we bring back Coulombs Law. The equation for modeling this is very similar to that of the law of gravity. However, instead of mass, this version of Coulombs Law addresses interaction between charged objects. Because charges can be positive or negative, this force can be positive or negative. Again, check out the simulations linked to this video to explore the relationship described in this slide. Let's bring back Katie from our gravitational forces example in the last video. Here, she has a ball in her hand. What forces are acting on the ball? In this case, both gravitational and electrostatic forces are acting on the ball. Gravity pulls the ball towards the center of the Earth, while the electrostatic force pushes the ball up because of the repulsion between the particles that make up the surface of the ball and those that make up Katie's hand. This repulsion is often overly simplified as a natural or normal force. The electrostatic force stops us from falling through the Earth and makes us hover over chairs, sort of. Check out this person sitting at their desk. Despite the fact that atoms are mostly empty space, the person won't fall through the chair because of the electrostatic repulsion between electrons. Gravity is pulling the person down towards the center of the Earth, and the electrostatic forces are pushing them back up. These forces are balanced, so the person doesn't move. If something is not moving, either there is no force acting on it, or the forces acting on it are equal and opposite. So we can sit on a chair because at that point, the force of gravity is equal to the electromagnetic force.